GATE 2017 Civil Engineering Set 2 Question 49. Water is pumped at a steady uniform flow rate of 0.01 meter cube per second through a horizontal smooth circular pipe of 100 mm diameter. Given that the Reynolds number is 800 and G is 9.81 meter per second square, the head loss in meters per kilometer length due to friction would be. The answer needs to be found up to 1 decimal place. The relevant NPTEL reference has been listed. So to find major head loss in a pipe, we use the Darcy-Weisbach equation. It is given by H equals F LV square divided by 2GD. Here H is the head loss in meters, F is the friction factor which is given by 64 divided by the Reynolds number, V is the average flow velocity in meter per second, D is the diameter of the pipe in meters, and L is the length of the pipe in meters. Using this we can obtain the head loss in the pipe. In this case we have been given the discharge value which is 0.01 meter cube per second. The diameter has been given as 100 millimeter. The value of Reynolds number is given as 800 and G is mentioned as 9.81 meter per second square. So the head loss is given as FLV square divided by 2GD. Here we need to find the head loss per unit length. So we will take L on the other side. So that would be H by L. This would give us the head loss per meter length equals FV square divided by 2GD. Here we have not been given with V, so we will need to find it. So V is equal to the flow rate divided by the area of the pipe. The flow rate is given in the problem itself as 0.01 meter cube per second divided by the area. The area for a circular pipe would be pi by 4 D square. Here D is given in millimeters, so we need to convert it to meters using the conversion factor of 10 to the power minus 3. This would give the value as 0.1 meters. Substituting the value here, we would get the value of V as 1.272 meters per second. Head loss would be equal to 64 divided by Reynolds number, that is 800, into V square, that is 1.272 whole square, divided by 2 times of G, that is given as 9.81, and D, which would be 0.1. This would give the value of head loss as 0.06597. This is per meter length head loss. But in the question it is asked to find the head loss per kilometer length. So the head loss per kilometer length would be this value into 10 cube. So that would result in 65.97. The question instructs to round it off to 1 decimal place. So this can be rounded off to 66. So the head loss in the pipe per kilometer length due to friction would be 66. The relevant NPTEL reference has been cited.